Hi folks, this is Tom. I appreciate all of the interest in the video on how to measure crystal frequencies. Today we're going to cheat a little bit. We're going to measure crystal frequencies, but we're going to use a real crystal impedance meter. This is the RFL Labs Model 459A, and this covers 0.8 megacycle to 15 megacycle crystals. What I've done is I've fired it up here with the variac, so we got 115 volts onto it. Nice soft start for it. We come out of the back with a BNC cable, and we're going to the input of a beautiful 1969 vintage Genrad Model 1191 frequency counter. And for today's test, we've rounded up the usual suspects, and what we're going to do is we're going to test these FT171B crystals. These are ones that go to my BC610. Let's start with the 3915 one we used in the first test. We're going to pop this into the front here, and this is cool. This is actually got a fitting right here so you can put different size crystals into it. Okay, the first thing you need to know about this is that the RF ammeter that's over here is very, very, very fragile. Don't ask me how I know this. Let's just say that I was very fortunate enough to find 4 spare thermocouple modules on eBay from a guy in Greece, and I bought them right on the spot, and I replaced the one that I burned out. So it's important when you use this piece of test equipment here that you literally have this thing turned down to 0 gain and 0 gain over here. We've gone ahead, we popped in the 3915 crystal. We've preset the unit here to the 3.4 to 5.1 megacycle band. So this thing should pop up. And now what we're going to do is we're going to do this little kabuki dance here. What I do is I advance the grid current on the oscillator tube here just a little bit, and I bring the crystal current, which is measured on the RF ammeter here, up slowly. What we do is we do this until hopefully we get a little bit of a movement on the other side of it. I'm going to crank this a little bit to see. Oh, here we go. There we go. See, we're actually tuning this in. And you can see we've got a definite peak right there. So what we're going to do now is we're going to slowly run this up. I like to run this at about 25 milliamps. No more really than that, because you don't want to either A, crack the crystal, or B, get really aggressive with this and blow up the thermocouple, because these probably have not been made in at least 50 or 60 years. And I'd like to back the grid current here down to about 50 microamps. We've got it on a load capacity of 32 picofarads, but if we wanted to, we could change to these different settings here: 13, 25, 32, 35, 50, and 100. Or we can go over here to 12 to 70, and there's a variable capacitor. But we're going to leave it on 32. That's a fairly common value right there. So I'm going to peak this again. There we go. And now let's take a look up here, see how we're doing. Oh, look! Don't you just love how this Nixie tube counter counts? So it looks like we're 3915.082 plus or minus a little bit. I got this calibrated about 1 or 2 parts per million, so we're within 4 cycles. We're within about 8 or 10 cycles there anyways. No worries. And we'll go back down here, and there we go. The other cool feature with this is that what we can do is we can actually measure the crystal impedance. What you do is you've got whatever current you're pulling here, and there's a calibrate function here. So what we can do is we can flip the switch, and what we do is we dial in this resistance box here until we get to the point where it matches what the current is there. So let's see, let's dial it down, and it goes up, and we're almost there. We're down to, let's see, 3 times 1, so that's that's over there. 3 times 10, that's 30 ohms, and we got the times 1 over here. Let's crank this one up, because it looks like we're gonna drop this down to 20 here, and bring this up to 50 mark, right about like so. Let's flip the switch. Yeah, it's practically identical. We think we need to crank, okay, crank that back up to 30. And yeah, we're within probably an ohm or two of that now. That's not moving at all. I think we're actually about 30 ohms on this right here. Pretty neat. And you can see as you touch the crystal, you change the capacity and you change the resonance of it. And we'll go up here, 3915.016. And I'm going to let go of this. And it went up. Yeah, that was about 80 cycle difference right there. And we're running about 25 mils. That's fine. We can actually run this up to about 100 mils now, just for the fun of it, just to see what it does. The current here is holding the same. Frequency is holding about the same. Let's go back down here, hit the calibrate. We're in calibrate now, and we're still about the same figure. So it looks like this crystal has about 30 ohms impedance on it. Not bad. Okay, let's pop another one in. And it's always a good idea when you change frequencies, change crystals, run stuff back down again, because again, this guy here is super fragile. You don't want to have any accidents here. Let's pop a 3955 in there. Okay, we got 3955. Let's goose that up a little bit. Looks like we're actually pretty close here because we're actually getting a little bit of current there. We're watching this very closely here. Neither one of these wants to go screaming. And now we're going to peak this one ever so slightly. And there we go. That's about 25 mils right there. Go back over here, drop this one back down to 50. Do this kabuki dance, 25 and 50. That looks good. And let's see where we're at. Hey, 3955.577. That's not bad. It's well within a kilocycle for something that's, again, the better part of 80 years old. And let's kick this in and see what this says. Oh, boy. Okay. That's got way too much current there. So we need to do is we need to run this up. And now we've gone the other way, a little bit too low. So now we're going to crank that one back one. And that's about it right there. Looks like this one is about 70 ohms impedance. Not bad. Oh, one other thing I wanted to show you is, let's watch what happens here as I run this up. Oh, crap, past where we were. Let me drop that back down. Yeah, there we go. Helps if I'm on the crystal setting as opposed to the calibrate setting. But watch what happens now. We've got two dips here, or two peaks, I should say. And if you're not careful, look what you're getting. You're getting a false peak here. We're actually at 59.46. And if I go ahead here now and bring this back in, you can probably watch it here as it changes. It's going down, 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 down. Oh, it's coming back up again, and look what happened. Now we're actually over here, and we're at 39.55, so that's just something to keep in mind. So if you see some oddball figure in here, what you want to do is crank it to where you know it's supposed to be. Well, that's pretty well the rundown on this guy here. We may do another video on this later on. I also have the big brother to this that goes from 10 megacycles, I think, to 110 megacycles, but it's not anywhere near as easy to work with as this is. If you actually open this up and look behind the panels here, there's some pretty long wire lengths here, whereas the higher frequency one, you can't get away with that stuff. And it's a lot more compact. If I remember correctly, I think we had to use some external resistors on that, and everything had to be real precise. Otherwise, you didn't get exact readings as far as impedance goes. But anyways, so much for this. Thanks for watching.